again, let's go to 1.3. No secrets whatsoever. Let me see which page I need. I need 124. Okay. Find the simplified form of the difference quotient. There is no secret. Oh, I didn't mean that. I meant to move this. Anything. This we know for 3 weeks already. Any function, or we can say move on.
Let's just do 10.
Okay, let's do 10. Negative 2x plus 5. So 10 on 122. So we have f of x, negative 2x plus 5. Can anyone refresh our memory on the difference quotient?
F of x plus h minus f of x all over h.
Thank you very much. And of course, can anyone now give us here on the side how to write f of x plus h?
Negative 2x minus 2h plus 5.
Very good. And we know what has to happen, right? Number one, terms without h from the numerator have to go away. Number two, this h in the denominator has to go away. And number three, h has to be still found or left in the final simplified form. Okay, so I have negative 2x minus 2h plus 5 minus this. Let me write it like this, just for everyone to see. We have to always change the signs. Divided by h. So negative 2x minus 2h plus 5 plus 2x minus 5 divided by h. All terms, maybe even more than just that, but definitely all terms without h must go away, and they do. And then negative 2h over h, negative 2h divided by h is negative 2. As expected, h has to go away. It happens for this is the simplest possible function. It's a linear function. It happens that there is no h left in the final form. This happens only for the ones that have a constant rate of change, because we know that the rate of change of this function is negative 2, constant, the slope. Very good. Good pick. Let's move on. Anything else? Use each graph to estimate the average rate of change of a percentage of new employees in that type of employment from this and this, from this, from this, from this and this. That's one option. Other options here, find the average rate of change between first 2 points or the first and the last point. You choose. All we need to do is the slope. Find the slope of the line.
We do 24.
24. Okay. So let's choose one set of years. Either 2003 to 2007 or 7 to 12 or 3 to 12. It's up to you. Choose one.
Let's do 3 to 12.
Very good. So between 2003 and 2012. Good. So problem 20. 2003. 2003. It appears that is 2003 is 0, 0, 1, 2, yep, 0. So 2003 comma 0, I read. Did we say 20 or 22? I'm sorry. I'm looking at 20. Okay. And let's read for 2012. For 2012, I read 2012, so it's 7, 8, 9, 10, 11, 12, correct. 2012, roughly 1. Roughly 1. So 2012, comma 1. Okay. So the average rate of change will be y2 minus y1 over x2 minus x1. So the top is 1, and the denominator is 12 minus 3, which is 9. If I do not write the measurement unit here, I will not get full credit. The measurement unit for any rate of change, like the slope, like the average rate of change, like the difference quotient, has to consist of one measurement unit coming from the numerator and another measurement unit coming from the denominator. I already know that the denominator is in years, so I have to write year. Now let's see what was. So this was number of employees, percent. Okay, so percent then. Percent per year. So please remember the measurement unit, always. So it's 1 over 9. Okay, let's see if there is anything else. Same thing. They're giving us a function. We're asked to find p of 6, p of 4, and the rate of change between 6 and 4. Basically between 4 and 6. The same thing, you choose. They're all absolutely the same. They're asking us to find the slope of the line. Same thing. You choose. So let's work on one more problem. They're all the same.
38.
I'm sorry?
38.
38. So let's take a look. The radar range. Very good. Perfect. 38 on 125. So the function given by r of x equals 11.74 times x to power 1/4. Very good. Can be used to approximate the maximum range r of x. Okay. So this is in miles. I'm taking notes. In miles of an ARSR-3 surveillance radar with a peak power of x watts. Fine. Find the rate at which the maximum radar range changes as peak power increases from 40,000. So x is in watts. So from x equals 40,000, so x1 equals 40,000 to x2 equals 60,000. Okay. And then they want us to find the average rate of change. Good. Excellent. Very good. So, oh, I didn't want to stop sharing. So we're going to put this function in y equals. So in y equals, clear if you have anything else. And punch in the function as 11.74 times x power, depending on your calculator, put in parentheses, please, the power. So 11.74 times x to 1/4. Then please go to second table and punch in 40,000 and then 60,000. After that, go to the right to read the whole number. So highlight in the column, in the y column, highlight the corresponding y value for x of 40,000 and then the rest, the other one. So I have r of x1, as I denoted it as 166.03, and this is miles. That's the measurement unit. And r of x2, scroll down one step, 183.74 miles. After that, get out of there, put parentheses for the numerator, which is y2 minus y1, so this is 183.74 minus 166.003, close the parenthesis, and divide by, I don't have to put parentheses because I can calculate x2 minus x1 as being 20,000. Otherwise, you would have to put parentheses. But 60,000 minus 40,000. So careful with this number. This means 0.4 decimal digits, including 8. So the average rate of change, I'm going to stop sharing in a second. I'm going to copy that. So r of x1 minus r of x2 divided by x2 minus x1. And we got 0.0008855. Measurement unit. So the numerator is measured in miles. The denominator is measured in watts. Any questions? Any questions? Any questions on the calculator work? Anything here? Any questions? Okay. Let's go back then. Where is my book? Here. They're all exactly the same. All we need to do is just find the average rate of change between different points on the graph with the population growth and everything else the same. Any questions? Okay, so I would like to at least start. So you're responsible for 1.2 and 1.3 for Tuesday. So in my lab math, as well as written homework. You're not responsible for 1.4. I'm not going to be able to finish it, but I'd like to start it. So far in this course, we talked about two major topics. So topics. We talked about a lot of things, but two major topics. One of them is the limit as x approaches something. And the other major topic was the difference quotient, which was f of x plus h minus f of x divided by h. Okay, stay with me, please. And that's the reason why I did not recycle this just yet. I'm going to copy this graph to see what happens next. Okay, so now I can recycle it. I don't need it anymore. Okay, here's my graph from last time. Here's a function. We have 2 points. We have point P, and we have point Q. Yes, we know how to determine the slope of this line. This is the x. This is tiny. This is tiny. But I have to zoom in. I cannot explain if I don't zoom in. So this is x plus a little bit. Of course, we know that this will be f of x. Of course, we know that this will be f of x plus h. You gave me all those a long time ago. I'm not interested anymore in the slope of the secant line or the slope of or the average rate of change. No, that is done. We got the idea. I want now to be able to determine the slope of this line, which is the tangent at P. This is what I want now. I want to find the slope of the tangent at P. So here's what I want to do. I determine this, which is the slope of the average rate of change, the slope of the secant line, the line that crosses the function in 2 points, minimum 2 points. But I want to move this point Q here, and then determine this slope. And then I'm going to move it here. I'm going to determine this slope. And I'm going to move it here. I'm going to determine this slope. I want to move it here. And I'm going to determine this slope. And I would like you to tell me what happens. So I want to move point Q to approach point P. Not the same. They're not overlapping. Q does not overlap. So what happens when I move Q closer and closer to P? What happens to H?
H approaches 0.
Very good. Excellent. Now, the slope of PQ, which is this, and when I move Q closer and closer to P, what will the slope approach?
The slope of the tangent line.
The slope of the tangent at P. But what is the slope of this? What is this? We determined it 3 weeks ago, and I've been torturing you with it for quite a long time.
Difference quotient.
Exactly. Thank you. Who said that? So this is this. We know that. This will approach the slope of the tangent at P. So this is the major concept that we just used. But we're not going to write it like this. I'm going to combine it with a limit. And if I put the limit in front of this, then I can change this symbol into equal. So I'll put the limit in front, limit of the difference quotient. When what?
When H approaches 0.
What will this equal then? Instead of putting approaches 0, I put the limit in front. We don't write it like this. I just wanted to explain it to you, how it works. But this is the way we write it. And I'll stop right here. I just want to mention this has a name. So this has a name. This has a name. This is an operator. This is a difference quotient. When we put them together, we get something called f prime of x, the slope of the tangent line, which is the derivative function of function f, the derivative function of f of x. Finally, I'm just going to write one sentence and I'll stop. This gives the slope of the tangent line, not just at P, anywhere you want. Gives the slope of the tangent line to the graph of f of x at any point. I have to put this in parentheses now, where f prime exists. Sorry. I'm going to write this again next time. It is possible